Okay, today we're going to look at how to solve some polynomials over the complex field. Okay, so let's look at the first one, solving complex equations. Z squared plus 3 equals 0. Okay, this one's an easy one. Move the 3 across. Okay, we can't do that unless we know about complex numbers. So we can change this to 3i squared because I squared is the same as -1. So then we get z equals plus or minus the square root of 3 times i. And that's it. Pretty easy for that one. Let's do another one. Let's do a quadratic. Another quadratic. Maybe a trinomial quadratic. Let's have a go at that one. Okay, let's try this one. Z squared plus 2z plus 3 equals 0. Okay, so what can we do here? Now, if you were to graph this, we could see that there's no z-intercepts or intercepts with the horizontal axis because it sits above the line, but there are complex solutions here. So if we complete the square, so z squared plus 2z, now to complete the square, I want to half this 2, square it and add it on. So half of 2 is 1, 1 squared is also 1. So add it on, so I'm going to keep that separate. But because I've added on 1, I need to minus it away, minus 1 away. And we've still got the 3 out here, so that's fine. Now this is a perfect square, so both the factors are the same. So we've got z, the square root of this one, square root of this one, and this sign. So plus 1 all squared. What have I got here? I've got plus 2 left over equals 0. Rearranging that one, I get z plus 1 all squared equals -2. Take the square root, so I get z plus 1 equals plus or minus the square root of -2. Oh, I forgot to do the I squared bit, so let's do the I squared bit. Z plus 1 plus or minus the square root of 2i squared. So I get z plus 1 equals plus or minus I root 2, if you like. Take out the I squared. Move the 1 across. Probably did too many steps here, but anyway, that's okay. -1 plus or minus I root 2. Okay, or root 2i. Okay, so we've got two solutions here. They're complex conjugates of each other because we've got they're just a change in the imaginary sign here. So they're complex conjugates. And that makes sense once you know the conjugate root theorem. Now the conjugate root theorem, before I rub this out, means if you have any polynomial that has real coefficients, okay, so there's no complex numbers in here. These numbers are all just our plain old real numbers. No i's in there at all. So if you get some complex solution, they'll always occur in conjugates. So if you can find one, you'll know that that's a complex root. Then you know that the conjugate will also be. This only occurs if these numbers are all real numbers. So if you have imaginary parts in there with a few i's, that is not the case. But as long as you've got real numbers for the coefficients in your polynomial, then you know any complex roots will be in conjugate pairs. Okay, so let's try another one. Let's say we've got a polynomial z equals z cubed minus 2z squared minus 5z minus 12. Okay, so now we've got a polynomial. All the coefficients are real. We've got 1, -2, -5, -12. They're all real numbers. That's fine. So if I do get some complex roots, then they have to occur in conjugate pairs. All right, I think I've said that enough now. Let's try and find, we know there has to be one real root for a cubic. So let's try and find the real root. Let's try. So we're looking at factors of 12. Let's just happen to try this one first, p of 4. So I'll try this one. I get 4 cubed minus 2 times 4 squared minus 5 times 4, minus 12. What do you know? 64, minus 32, minus 20, minus 12. Adding all up. Minus 32 is 32, minus 20 is 12, minus 12 is 0. Wonderful. Therefore, z minus 4 must be a factor. Okay, so that's our real factor. Let's see, I'll put this over here. Let's see if we can find our other factors. Okay, so, well, let's not do long division. We could do long division. Write this out, do long division. That's fine. We could have done that. Let's just work it out because it's a pretty easy one. So z minus 4 is one of our factors. So what do the other factors have to be? Now, when we expand it out, we've got to get this. Okay. So the only way to get this z cubed is by multiplying this by the first thing. So z times what is going to give me z cubed, or z squared. Yeah. So z times z squared gives me z cubed. That's the only possible thing I could put there. The only way to get the negative 12 is negative 4 times whatever number's here. So negative 4 times something has to equal negative 12. So it's a positive 3. So that's easy. So now it's just this, we've got a quadratic in here. So we're just going to see what our coefficient of the z term is. Now we can just pick one of these. Let's pick the z squared. So we've got to get negative 2z squared. So how do I get a z squared? I can multiply these two together. And I can multiply the z times whatever this number is. So I've got negative 4z squared. I've got to add something onto it to get negative 2z squared. And that happens by multiplying this bit together. These ones together. So it's got to be positive 2z. Yeah. So we'll just check and make sure that's right. Do I get negative 5 here? Right? Do I get negative 5 when I expand out? So the way I get that is I go, well, these two terms multiplied together, and then these two terms multiplied together gives a z. Yeah, negative 4 times 2z, that's negative 8z, plus 3z is negative 5z. So that's it. That's all we have to do. We could have done a whole long division, but that would have taken ages. So we know what the factors are now. We've got this quadratic factor, this one, and here we've got the same one as we had before. So we know z minus 4 is a factor, and our solutions to this one was negative 1 plus or minus root 2i. So let's write that out in factor form first. So z plus 1 plus root 2i, and z plus 1 minus root 2i. Okay, so if we want the roots, we just set this whole thing equal to 0 and use null factor law. Gives me z equals 4, or z equals negative 1 plus or minus root 2i. And we get all three roots. Fantastic. Let's keep going. Let's do another one. Okay, what if we also had, alright, we can find another p of z, another polynomial. If we had z cubed minus iz squared minus 1 plus 2i z minus 6 minus 3i. Okay, what do we have in this scenario? This scenario, we don't have all real coefficients, yeah? We've got complex coefficients here. All right, so, but we might be given a factor. So we might be given z minus 2 minus I is a factor. Okay, so if we're given that, we could try and do some long division. So let's give that a go. We might give that a go in green. Might need to make some more room here. Z minus 2i z cubed minus I z squared minus 1 plus 2i z minus 6 minus 3i. Okay, so what do we get when we multiply that in? So we'll divide it, really. Z cubed divided by z, that's z squared. Z squared times z is z cubed. Z cubed minus 2i is minus 2. Oh, hang on, it's minus 2 minus I. Ooh, lucky I didn't make that mistake. That would have sent me in the wrong direction. Let's go again. Z squared. So I've got all of this minus 2 minus I. Let's put a little plus sign there and put it in brackets. Z squared, plus sign. Ugh, it's messy already. Okay, z cubed minus z cubed, because we're going to minus all this away. So z cubed minus z cubed is 0. What do I get here? I've got negative I minus negative I, so it's we're going to plus the i's together, and we're going to minus away this negative, so we'll end up with positive 2z squared. Try not to mix up your negatives, that could end in disaster. So what have I got left over? I've got 1 plus 2i, z minus 6 minus 3i. Okay, now let's go again. So I get plus 2z. So I get 2z times that is plus 2z squared. That's what I want. 2 times this. So I'm going to go minus 2 times. I'm going to change this to 2 plus I, because I made this a minus out the front, so taking the minus out. Z. I'm trying to make it easier, believe it or not. I want to minus all that away from each other. So I get this minus this, that's 0, that's perfect. Now I want to go minus this, but plus twice of this. So I've got minus 1 plus 4. That gives me 3, yeah, for the reals and the imaginary bits. I've got minus 2 plus 2i. Okay, so we've got minus 2i plus 2i, 2 times I. So that ends up with 0i. So I just end up with 3z. So here we go. We've got 3z minus 0 here. So we get 6 minus 3i. Expand it in. I get plus 3. Oops. It's very messy. There we go. Plus 3. 3 times that. 3z. Perfect. 3 times this. It's minus 6 minus 3i. Perfect. We wanted that to be the case because we knew this had to be a factor, so it had to come out as with a 0 remainder. And then we've got our good friend, which we've met before, z squared plus 2z plus 3. So now we know all the roots because we've already solved this. We've just solved it the same way as we did before. We've got z equals 2 plus I, or z equals negative 1 plus or minus root 2i. Okay, so there's our 3 roots. Fantastic. That's if we're given a factor. That worked well. There may be a type of question that they expect you to do in year 12 where they don't give you what the factor is, or they don't give you a clue about what that complex factor may be. So you could have a question something along the lines of P of z equals z cubed minus 3iz, 3iz squared, sorry, plus 2z minus 6i. And in this scenario, they want you to try grouping. So to group, let's just group in an order that's convenient for us. Here we go. And you take out common factors. So what are some common factors of this first bracket? Z squared's common. So it leaves me with z minus 3i. Yeah, if you expand that out, you get this bracket. And common factor of this one, plus 2. Z minus 3i. Okay, I know that grouping has been successful because both of these brackets are the same. which is what I was aiming to do. So since both of those brackets are the same, I can take them out of both terms. So I can take the z minus 3i out of both terms, and I'm left with z squared plus 2. Z squared plus 2. Okay, so I'm trying to find the roots. Let's put this equal to 0. So I've got z minus 3i equals 0, or z squared plus 2 equals 0. Okay, so I get z equals 3i, or z, now I get negative, I make it I squared, so I get z equals plus minus I root 2, which we had before as well. Oh, we had a similar one anyway. We had root 3, didn't we? Okay, so that's it. So give grouping a go. If grouping doesn't work, then maybe you can find a factor and you can do long division if you have to. Okay, that's it.